So in this class, I will discuss about a problem of equilibrium of a connected system. So connected bodies means, for example, here I have taken an example of cables. So there are three cables here, A, B, BC and CD. These three cables are connected. So at the joints B and C, there are two weights, 20 kN and 30 kN given, and the inclinations of these cables are as given. Now the question here is, you know that cables and strings, they are capable of carrying tension force. So the question here is, for the equilibrium of the entire system, for the equilibrium of the entire system, determine the tensions in the cables. Determine the tensions in the cables. So cables are AB, BC and CD, and also the inclination theta. Inclination theta as shown in figure. So there are four unknowns here. So theta is this. It is the angle made with the vertical at D of this cable CD. Now there are four unknowns here: tension in this cable, tension in this cable, and tension in this cable, and also this theta. So four equations will require to analyze this problem. Let us take the values of the tension forces in these cables as. So since it is tension, please note that tension force is designated by a force acting away from the joint. Now A is here, B is here, this is one cable. So from A you have to take away from A, from B also you have to take away from B like this. So this tension force is T1. Then the tension force in BC, I will take away from B as well as away from C. This tension force is T2. Tension force in CD, I will take away from C and away from D, that is T3. Now the unknowns are now T1, T2, T3, they are the tension forces in the three cables as well as theta. So these are the unknown forces. So four unknowns are there. We have to find out those unknowns by developing four equations using the conditions of equilibrium. So for that, what we have to do is, we have to take the free body diagram of these joints. So it is like this. I told you how to write the free body diagram. First I will write free body diagram of joint B, where two cables are meeting. So the two cables are connected at B, AB and BC, they are connected. If I write the free body diagram of joint B, so it will be something like this. So this is A, this is B. So this is the free body diagram. And from B it runs one more, it runs. So it is like this. C will run here, A will be here. So this is joint B. At joint B, there is a force given 20 kN and the angle given is 50 degrees. So this is what the force is acting at B. Now we have to take the tension force also at B. So at B you have force away from B, T1 and T2. Please note that when you are writing the free body diagram of joint, we have to write down the members, that is the cables which are meeting at joint B, and the corresponding forces, tension forces acting with the exact directions. Now here, this angle is given as 30 degrees, therefore this will be 60 degrees. Definitely, because if you write a rectangle triangle, this will be 60. Now we have to, there are two unknowns, T1 and T2. So we have to get two equations. Either you can use Landis theorem or you can use equilibrium equations to analyze this problem. So this becomes a concurrent force system because there are three forces here, 20 kN, T1 and T2. They are meeting at this common point B. Now let me use sigma equals 0 for equilibrium equation. Rotating forces acting towards right positive. Now here we have to resolve this T1 and T2 along horizontal and vertical directions. Let me take the global x-axis and global y-axis. So if you resolve this T1, so T1 force will be, if it is resolved, it will be like this. So I have it like this, it is in second quadrant. So this becomes T1 cos 60, because 60 degrees is the angle made with the horizontal, this becomes T1 sin 60. Whereas if you resolve this T2, if you draw a horizontal here, this angle becomes 40 degrees because total is 90, 90 minus 50, 40. If you resolve this, arrow is like this. If you resolve that, horizontal will be like this, vertical will be like this. So this becomes T2 cos 40. Please note that. This 40 is the angle made with the horizontal, and this becomes T2 sin 40. So now this is the resolution. Of course, 20 kN force is acting vertically, you need not resolve that. Now sigma Fx0 if you apply, taking force acting towards right positive, this is negative. So minus T1 cos 60 towards left it is acting. This is plus T2 cos 40. Of course, this 20 kN doesn't have any horizontal component, so therefore is equal to 0. So this is the first equation we are going to get by taking sigma Fx0. Next equation is sigma Fy0 by treating upward forces positive, downward forces negative. If you use this equation, then this T1 sin 60 is positive because it is acting upwards, whereas this T2 sin 40 is negative because it is acting downwards, and this 20 kN is also negative because it is acting downwards. So minus 20 is equal to 0. So the LHS term is sigma Fy and RHS is 0 for equilibrium. This is the second equation. Now we have to solve this first and second equation to get the values of T1 and T2. So solving equations 1 and 2. So T1 and T2 we are going to get. So how to solve that? You know how to solve these two by using the calculator. If you solve that, you are going to get the answer. Please try to solve that. T1 you are going to get 44.79 and T2 29.24. 44.79. Please check that. Newton. Since the kilonewton, because the weight is given in kilonewton, same means we are going to get the tension force, and the T2 value is 29.24. 29.24. So if you know how to write the equation, then solve the equation using the calculator. You will get the two values T1 and T2. Next, on similar lines, you write down the free body diagram at joint. Free body diagram of joint C. There also two members are meeting. So here, so what happens? Joint C is here. So B will be here and D will be here like this. And this angle he has given theta. And here, of course, when that becomes theta, here, if you draw a horizontal, this becomes 90 minus theta. And the forces, tension force away from C we have to take. This is how. This is P2. Please see here. So this is joint C. Away from in the direction CB, you have tension force P2. In this direction, we have a tension force T3. So this is T3, like this. So here, T2 already you know. T2 value we have found out. It is equal to 29.24. 29.24 kN. And of course, at C, they has given a 30 kN force as the weight. It is weight because it is acting vertically. There is an object which weighs 20 kN at C. So this is diagram. And this angle also we need. This angle, as you know, here from this diagram, so this is C, angle C. So since this is 50, this becomes 40. When this becomes, so that value, that angle becomes 40. So you should be very careful about angles. This right angle triangle. When this is 50, this is 90, therefore this should be 40. Now, once again, you have to use the same principle. You have resolved the forces along the two perpendicular directions, x-axis and y-axis. So if I resolve this, horizontal will be like this, vertical will be like this. So this is 29.24 cos 40 and this is 29.24 sin 40. Okay. Then when you resolve this T3, please be careful here. This angle becomes 90 minus theta, this becomes theta. So when you are resolving, this is acting in the first quadrant. Therefore horizontal will be like this and vertical will be like this. So T3 is unknown here. So this is T3 cos 90 minus theta, which is same as T3 sin theta, whereas this becomes T3 cos theta. When this is T3 sin theta, this becomes T3 sin 90 minus theta, which is T3 cos theta. Now this is how we can resolve the forces. Now let us apply the equations of equilibrium for this joint C. Now sigma Fx is equal to 0. On similar lines, force is acting towards right positive. So this is negative minus 29.24 cos 40 degrees. This becomes positive, that is plus T3 sin theta, we get here, and this doesn't have any horizontal component, therefore it is equal to 0. This is equation 3. Next, equation 4 will be sigma Fy is equal to 0 at joint C. Upward positive, downward negative you take. So this is positive 29.24 because it is acting upwards, sin 40 degree. Whereas this is 20 is negative, so I think it is not 20, it is 30. At C it is 30, yeah. So please be careful there, minus 30 because it is acting downwards, and this is positive, plus T3 cos theta. So this is positive. Now this is equal to 0. So this is equation 4. Now using these two equations, so you have to solve these two equations. Solving 3 and 4, T3 and theta can be found. So now how to solve this? That is the question. So from the first equation, that is from equation 3, you can get an expression for T3 sin theta. Equation 4, you can get an expression for T3 cos theta. Then you can divide one by the other to get the tan theta. So this is how we can do. So let me solve that. So equation 3 becomes now equation. I will take equation 3 divided by equation 4. So if you do this, equation 3 divided by equation 4, so LHS should be divided by LHS, RHS should be divided by RHS. Now the equation 3 can be written as T3 sin theta is equal to, so this should come to that side, 29.24 into cos 40 will come to the RHS. So 29.24 into cos 40 is 22.399 or 22.4. You can take 22.4. Similarly, from equation 4, T3 cos theta will be, so you have to bring this to that side. So once again this becomes negative, this becomes positive. So that is 30 minus 29.24 into sin 40, so which is 11.2. So this is 11.2. Now if you divide this by this, equation 3 by this is equation 3, this is equation 4. If you divide, the LHS if you divide, it becomes tan theta. So T3 sin theta divided by T3 cos theta is equal to 22.4 divided by 11.2, or you can take this as tan theta. So tan theta is equal to sin theta by cos theta is tan theta, which is exactly 2 here. So therefore theta is equal to tan inverse of 2, which comes out to be, so I will take tan inverse of 2 is equal to 63.43 degrees. 63.43 degrees. So this is the angle with which this cable CD makes with the vertical. So 63.43 degree. Now substitute this value of theta in one of these two. So we have T3 sin theta. T3 sin theta is equal to 22.4. Therefore T3 is equal to 22.4 divided by sin theta, which is 22.4 divided by sin of 63.43 degrees, which comes out to be 22.4 divided by sin 63.43, which comes out to be 25.05 kilonewton. So this is the tension in the third cable, that is in this cable. So that means whenever a connected body's problem is given, when bodies are connected with cables or strings, those cables will develop tension force within them for equilibrium, and we have to consider each joint separately, and we have to analyze those joints either by equations of equilibrium or by Navier theorem if the number of unknowns, number of forces acting at the joint is restricted to 3. If it is more than 3, as already told, in any problem, we if the number of forces exceed 3, then we have to go for equilibrium equations only. We cannot analyze using Navi's theorem. So this is how we have to do the analysis of problems of equilibrium of connected bodies. And of course, all these in both the cases, in both the joints, the forces are concurrent forces. So only two unknowns will be there. So you can analyze by using the two equations of